Hello everybody, welcome back. So today I'm going to be doing a small mini lesson of average rate of growth. This was recommended by Tiny Fronts. So average rate of growth is just so we're going to do it of a polynomial. So I want to graph a polynomial. Let's do that. 90 degrees. Okay, there you go. So now this is our coordinate plane, and we might as well just label x, y, not negative x, just x. So now let's say we had some random polynomial. I'm going to do a cubic. So maybe, oops. Actually, first I might as well just graph some random points I might go through. So that one, that one, that one, this one, and then maybe this one and this one. Okay, so it might start off going to negative infinity, and then it goes up, and then it goes down, and then it goes up again, and then it goes on to infinity. So now it looks kind of like that, right? So now I want to find the average rate of growth between these 2 points. So I'm going to put them in blue. This one and this one. So I'm going to put what they are. What color should I use? I'm going to use this one. Why not? So this point is this -3, comma -1, -2, 3, 4, 5, 6, 7, 8, 9, 10, 11, -11. Oopsie daisies. So this one is gonna be 1, 2, 3, 4, 5, 6, 7, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the average rate of growth, oh by the way, let's draw a line between them, because why not? The average rate of growth is kind of like the slope of the line between those 2 points. But obviously the polynomial might go like that, then the average rate of growth will become less accurate. So the closer the 2 points are, the more accurate the formula that we're going to use is going to be. But when you get to calculus, you're going to get into the derivative, which is going to be far more accurate, but a little bit more complicated. So here we can just use a simple formula. So we look at that line, and let's say one point was just, I'm just going to do general form. So this is a comma b, and this is c comma d. Or sorry, no. Oops, yeah. So I'm gonna say that this polynomial is y equals f of x, right? So now this point is gonna be a comma f of a, right? That's the y value. It's gonna be b comma f of b. So the slope of that line is a rate of growth, average rate of growth. But because remember how I said, oops, right? And now how I can now that be very less accurate. But on the other hand, if you can still have that ugly thingy, right? Let's say you had like that, and then you did like that. Very inaccurate, but still, it'll work. Obviously that white will not be a function because the 2 points with the same x but different y, but it's okay. It's okay. But so let me draw an accurate one then. So let's say you had, right, and then you wanted to find the average rate, right? That will be less accurate, but it's only between those 2 points. And then in calculus, you'll learn that you can infinitely zoom in and this will just become one line, and this will become a different line, and this will become a different line. So this is a composition of many lines, right? And then you can do some cool stuff with that. But we're not in calculus, we're in algebra, and we're kind of stuck just looking at this, thinking, okay, how can we find the slope between a comma f of a and b comma f of b? So what you do is the slope, remember, is y1 minus y2 over x1 minus x2, or y2 minus y1 minus x2 over x1. I'm going to write those. So, oops. So we have y1 minus y2 over x1 minus x2, but that's also y2 minus y1 over x2 minus x1. So whichever one will fit, and whichever one will be nicer. So in this case, we'll have our formula to be the y values subtracted. So f of b minus f of a over b minus a. Remember, you can't swap one of them and then keep the top, or vice versa. You just can't do that. So here we have to make sure that these two correspond and these two correspond. Right? These two correspond, these two correspond, these two correspond, these two correspond as coordinate points. So here okay, so now this is a formula for average rate of change. Okay? So if you're still confused about this b comma f of b and a comma f of a, well, let's say the x coordinate was a, right? And we have y equals f of x. So if the x coordinate is a, then y is equal to f of a. And there you go. Same for b. So y equals f of b. Remember, you just plug those in. And then this is the x value. So our coordinate point is going to be x comma y. And then we have a comma f of a and b comma f of b. So now, this is a formula for average rate of change. This was the main thing I wanted to talk about today. So now let's apply it with this. So, oops. So, what is the average rate of change between these 2 points? Well, we have f, and I don't want you to look at the formula. Well, I'll let you try it. 7 comma 11 and negative 3 comma negative 11. Doesn't matter what order you do the formula in. Okay, hopefully you've tried it by now. The formula is f of b minus f of a over b minus a. So let's use that here. We have so we're going to use the y value of 1 point, so let's say 11, minus the y value of the other point. So if the y value of this second point is negative 11. Again, we can also do negative 11 minus 11. We can switch them, and that over the subtraction of the x value points. But because we did 11 first, which is this point, then we have to do the x coordinate of this point. So that's going to be 7. Why does it keep going there? So it's going to be 7. The x value of the point with the y value of 11 is 7, minus the x value of the other point, which the x value of the point which has a y value of negative 11 is negative 3. Again, we can switch both of them, and we can also get negative 11 minus 11 over negative 3 minus 7. And this one equals, or let me do this one first. This one equals 11 minus negative 11. That's 11 plus 11, so that's 22. Stop going there. It's 22 over 7 minus negative 3 is 7 plus 3, or 10. You can reduce this fraction into 11 over 5. So the average rate of growth is 11 over 5. That's how it grows. So now here, we can also have negative 22 over negative 10. The negatives cancel and we still get 11 over 5. So that's how average rate of growth works. Average rate of change works. if you had two different, like if you had these 2 points, if you create the line, it'll be less accurate. But maybe if you were to, what you could do is you can create all of these points, and then you have just lines. 1 line, 2 line, 3 line, 4 line. And then, yeah. So anyways, this was just a mini lesson. Thanks for watching, and hope you guys learned something from this, and I'll see you guys next time. Goodbye.